All right, we're going to be using systems to solve puzzle problems, and specifically like digit problems here. So digit problems are based on our decimal system of numeration. So note that the value of 537, 604, and a number with the digits H, T, and U. So we're looking at these variables representing particular places on a number. So let's first look at number 537. So 537, the 5 is in the hundreds place, the 3 is in the tens place, and 7 is in the units place. So we can play that out over here and as a value as 5 times 100 because it's in the hundreds place and that's where it's located. The 3 is in the tens place, so that's times 10 because that's where it's located. And 7 is in the units place or the ones place. And we can play that out in that equation. We can also do the same thing with 604. So 604, we have 6 in the hundreds place, 0 in the tens place, and 4 in the units place, or the ones place. And I've spread those out because, again, that's where they are located. So when we look at the value of it, 6 times 100, it's because it's in the hundreds place. 0 times 10, because that's in the tens place. And this should be a 4. But 4 times 1, because it is in the units place. And we can use that information, stuff we know, to find stuff we don't know. Like, for instance, the 3-digit number HTU. H can be in the hundreds place, which we can play out over here as H times 100. T can be in the tens place, my second digit, and T times 10. And then my last digit could be represented as U as an unknown, and whatever that is, that's times 1 in the units place. So we can take a number that we don't know, a 3-digit number, and set it up as a value. Using this, we can solve some puzzle problems. Like, for instance, on this one. The sum of the digits in a 2-digit number is 12. Okay, so it's a 2-digit number, so we know that we're going to have a number in the tens place, and we're going to have a number in the units place. And then we're going to have its value. That we know. Let's see, the new number obtained when the digits are reversed than the original number. So we've got two things playing over here. We have an original number, and we have a new number. Okay, the sum of the digits, so we don't know this number. So in the tens place, we have a T, and in the units place, we have a U. And its value is going to be 10 times T, because it's in the tens place, as we saw in the previous slide, plus U. Now let's look at the new number. The new number obtained is when the digits are reversed. Okay, so U is going to be in the tens place, and T is going to be in the units place. But when we look at its value, it's 10 times the U, because it's in the tens place, plus T, because that is in the units place. Okay, now that we know this, we can continue to solve some of these things. So we're going to find the original number. So let's look at what we know. The sum of the digits and the sum of the digits in the 2-digit number is 12. So we know, firstly, is that T plus U is 12. We know their sum is 12. The new number obtained when the digits are reversed in 30 is 36 more than the original number. Okay, so that tells us that the new number obtained, so if we take our new number, let's look at the second one. If we take our new number, which is 10U plus T, and we subtract it from the old number, or the original number, it should be 36. So let's read that again. The new number obtained when the digits are reversed is 36 more than the original number. We can see how I get that is, this equation is when I look up here, I see that the new number, which is 10U plus T, is 36 more than the original number, 10T plus U. And I subtracted both sides by 10T plus U, and that's why it ends up over here. You can solve this in a couple different ways. And here's our couple of equations. So when I look at that second equation, I'm going to kind of clean that up a little bit. I'm going to get these terms. Okay, I'm going to distribute this out so we can see it. Minus 10t minus u equals 36. Combine like terms, I end up with 9u minus 9t equals 36. Divide by 9, and I get u minus t equals 4. Okay, so I have my 2. I've got one here, and I've got one here, and I can go ahead and line them up. I can do u minus t equals 4, and let's see, I'm gonna take, so this one's right here, this one right here, I'm gonna switch the order around so that I can use it, so it's u plus t equals 12, and then I can add them together. Cancel out, I have tu equals 16 divided by 2, so in the units place, I have 8 as my number. Well, now I'm gonna pick an equation to use to solve this. I can use any of them. I kind of like that one. I do know what's in the units place, so I can do 8 plus t equals 12. Let's make sure I'm using the right one. Yep. Subtract 8 from both sides. T equals 4. So if I look at my original question, it's asking me find the original number. The original number is 4 is in the tens place, 8 is in the units place. The original number is 48. Can also do this using age problems. So Mimi is 4 years older than Ronald. 5 years ago, she was twice as old as he was. Find their ages. I'm going to use a table to kind of organize it a little bit. So the two people we're considering here is Mimi, and we have Ronald. And the couple things we know about them is we've got their age now, and we got their age 5 years ago. So let's look at what we know. We know, let's go with Mimi's age, and we have Ronald's age. And Mimi is 4 years older than Ronald. So if Mimi is 4 years older than Ronald, that would mean that 5 years ago, Mimi is minus 5. And if that's the case, Ronald in that place 5 years ago. Actually, if we just look at the situation 5 years ago, whatever their age are now, it's going to be minus 5. So Mimi minus 5. So if Mimi was now 15 years old, 5 years ago she was 10. Mimi minus 5. If Ronald was 20, 5 years ago he was 15. Okay. Now let's look at some of the equations that we have to work with up in our story. Mimi is 4 years older than Ronald. So whatever Ronald's age is, it's plus 4. Okay. Let's look at our second equation. Let's see what else we can use from the story. 5 years ago, she was twice as old as he was. Okay, so that tells me that I can use this. So 5 years ago, so there's 5 years ago, Mimi was, okay, 5 years older than Ronald. So there's Ronald's age, and it was 5 years ago. Okay. I'm going to go ahead and distribute these out so I can take a look at this. All right, so when I'm looking at this second equation here, I'm seeing that Mimi's age 5 years ago is right here, and then that equals Ron's age, but I had to multiply it by 5. Now, actually, she doubled it, so I need to change that. So it's doubled the age, not, there it is, doubled Ronald's age. All right, well now I know, because I know what m is, I'm going to go ahead and substitute it in here because I need to start solving for something here. So I'm going to use some substitution to solve for this. R minus 1 equals, let's distribute this out. Minus 10. Let's do do some combining terms. I'm going to go ahead and subtract my r's, get those over in the right spots. I have negative 1 equals r minus 10. I'm going to add 10 to both sides, so then I can see that r equals 9. So in this case, we can see that Ronald equals 9, and I can then use this equation up here to finish this off. So if I know what r is, I can just plug it right in. Equals 4. Mimi equals 13. So I can use this information to see that Ronald is 9 and Mimi is 13. To answer the question, find their ages. Let's look at a fraction problem. The numerator of a fraction is 3 less than the denominator. So let's get a couple pieces here. So we're going to use n to represent the numerator. But that's going to be of the original because it looks like it's changing. And then d will represent the denominator, also of the original. Okay, so they're each increased by 1, and the value of the resulting fraction is 3/4. Find the original fraction. Okay, so we know that our fraction is going to look like this. That's our original fraction. So let's start off here. So the numerator of the fraction, is 3 less than the denominator. So whatever my denominator is, it's going to be 3 less. So my numerator is 3 less than my denominator. Okay, that's my first equation. Let's look at the second equation. If the numerator and the denominator are each increased by 1, so if the numerator and the denominator are all increased by 1, their value is going to be 3/4. All right, to solve this one, I'm going to do some cross products here. So I'm going to go ahead and multiply each side here. So I can do 3 times d plus 1 is going to be equal to 4 times n plus 1. And then I can go ahead and distribute those out. And I end up with 3d plus 3 equals 4n plus 4. And I can keep simplifying on this one. I can subtract 4n from both sides. So I can end up with 3d minus 4n plus 3 equals 4. I can subtract 3 from both sides. So I end up with 3d minus 4n equals 1. Now I have my two equations. So I've got 3d minus 4n equals 1. And then I've got my original equation from up here. I'm going to pull down. N equals d minus 3. I'm going to take my second equation here and move a few things around so that I can use them. So just so I can stack my terms, I'm going to rewrite it over here. So I have 3d minus 4n. That d didn't get any better. And then my new equation, moving some things around, is minus d plus n equals negative 3. But to use elimination on this one, I'm going to go ahead and multiply everything by 3. So again, I'm altering my equation one more time to be negative 3d multiply right here plus 3n equals multiply here. Remember to multiply all the way through. It's negative 9. I'm going to pull my top one all the way down. 3d minus 4n equals 1. So a lot of work moving things around. N equals negative 8. Multiply or divide both things by negative 1, and I have n equals 8. Let's use that n equals 8 in one of my equations. I'm going to use the top one. That seems to be one of the easiest ones here. There we go. So I know that my numerator is 8 equals d minus 3. I will add 3 to both sides. I know that my denominator is 11, so that my fraction is my numerator, I said was 8, and my denominator is 11. So my original fraction is 8/11. All right, we'll keep practicing this stuff. I'm going to go have a staring contest with a gerbil.